Your car starts shaking at idle. You take it to a shop. They plug in a scanner for $150 and hand you an estimate for $800 more. What they will never tell you is that the fix costs $4 at any auto parts store. 15 minutes in your driveway. No lift, no special tools. That $4 fix is one of 11 in this video. And the most expensive mistake on this list is not a broken part. It is trusting someone who profits from your confusion. Most drivers skip trick number 11 entirely. It sits completely out of sight, buried under the car. If you drive a rear-wheel drive vehicle, a truck, or any all-wheel drive car, and you have ever heard a low whine from the rear that intensifies under acceleration, your differential is telling you something. And if you have never heard it but have also never changed the gear oil, you may be one hard toe away from finding out what that repair costs. The differential gears sit in thick oil designed to withstand extreme pressure and heat. Over time, the oil breaks down, the additives deplete, and metal surfaces start contacting each other. The whine is what that sounds like. The job is simple, but one sequence catches people every time. Always remove the fill plug first. Not the drain, the fill plug first. Because if you drain the oil and then discover the fill plug is seized or stripped, you are stuck with an empty differential and no way to refill it. When you pull the magnetic drain plug, inspect it. Fine metallic paste is normal. Chunks or flakes indicate wear worth investigating. Refill with a fluid pump until oil seeps from the fill port. That seep is your level indicator. Limited slip differentials need friction modifier additive or a gear oil that already contains it. Running standard gear oil in a limited slip causes chatter through every turn. On a BMW E60 M5, the rear differential is a limited slip unit, and a short break-in period after a fluid change, driving with turns in both directions, helps coat the clutch plates evenly. A differential at least announces its problems with sound. What comes next fails silently and gets misdiagnosed more than anything else in the entire engine bay. Trick number 10 generates the most expensive misdiagnoses at repair shops. An engine starts shaking violently at idle. RPMs bounce at a stoplight. Sometimes the check engine light flickers. Sometimes oil shows up where it should not be. I have watched shops present this exact list to customers and charge accordingly. Possible fuel injector fouling, $300. Possible throttle body issues, $250. In alarming cases, they mention catalytic converter contamination, and that bill reaches over $1,000. And you are sitting there thinking something that expensive must be complicated. It is not. What the shop almost never checks is a small plastic valve tucked into a hose on the engine. $4 at any auto parts store. 15 minutes with basic hand tools. That valve controls positive crankcase ventilation. Every running engine produces combustion gas that escapes past the piston rings into the crankcase. If those gases build up, pressure pushes oil past seals, creates sludge, and accelerates wear throughout the engine. The PCV valve routes those gases back into the intake to be burned. When it fails, the symptoms look alarming. Visible oil leaks from multiple locations. Increased oil consumption. A violently unstable idle. Hissing under the hood. The test takes 45 seconds. Pull the valve out of its hose and shake it. A healthy valve rattles freely. A stuck valve is silent, dead. If yours does not rattle, swap in the $4 replacement. In many cases, every alarming symptom disappears within a week. For a more complete check, blow compressed air through the removed valve and confirm airflow goes in one direction only. If the valve keeps clogging after replacement, something else is wrong upstream. Degraded seals, oil-contaminated intake runners, or engine wear producing more blow-by than the system was designed to handle. The valve is not the disease, it is the symptom. Ford F-150 owners running the 3.5-liter EcoBoost should know that two PCV valve variants exist for that engine, a brown higher flow valve and a black lower flow valve. Ford technical service bulletins have recommended the higher flow version on certain VIN ranges to address fuel odor and oil overfill symptoms. Connected to the PCV system, but doing a completely different job, is the EVAP purge valve. This one controls fuel vapors from the charcoal canister, routing them into the intake to be burned. When it fails, you typically get EVAP codes like P0442, P0455, or P0446. Test the valve by applying 12 volts and listening for a click. It should seal when unpowered and allow airflow when energized. If you replace a purge valve and the code comes back, check your charcoal canister. A deteriorating canister sends contamination downstream and destroys the new valve. You have to inspect the whole EVAP circuit when codes keep recurring. Everything in Trick 10 assumes the intake system is sealed. A vacuum leak happens when unmetered air enters the intake manifold through a cracked hose, a loose fitting, or a failing gasket. This extra air upsets the air-fuel mixture and causes the engine to stumble and hunt for idle speed. Pair your leak detection method with a scan tool. Watch your short-term fuel trims while you spray carburetor cleaner around suspected leak points. If you see enrichment happening when you hit a specific area, you found your leak, even if the idle did not visibly change. Keep a fire extinguisher nearby. Carburetor cleaner near a running engine demands respect. The professional alternative is a smoke machine, which pressurizes the intake with non-flammable smoke and shows you exactly where it exits. Many auto parts stores rent them. For Honda Civic owners, a shaking idle that fluctuates often maps to the PCV valve first, then vacuum hoses, then the passenger side hydraulic engine mount. Start cheap. Vacuum leaks are invisible. Number 9 involves something you can actually see. And one free test in this section has saved people from buying $400 coil packs that were never the problem. Trick 9 is where your engine creates the spark. When was the last time you actually pulled a coil boot off and looked down into the spark plug well? Because what hides down there is one of the most common causes of misfires and one of the cheapest things to fix. Before you buy a new coil, do the coil swap test. If you have a misfire on cylinder 2, move the coil from cylinder 2 to cylinder 4. Clear the codes, start the engine. If the misfire follows the coil to cylinder 4, the coil is bad. If the misfire stays on cylinder 2, the coil was fine. And the problem is the plug or the wiring. Coil packs at the dealership run $240 each. The swap test costs nothing. Let that sink in. Always check plug wells for oil intrusion. Oil pooling in a plug well means a valve cover gasket or plug tube seal is leaking, and that oil creates arcing paths that cause misfires, regardless of coil condition. The spark plug gap governs how hard the coils work. When the gap widens from electrode wear, the coil must generate higher voltage to bridge that distance. A coil that is already marginal gets pushed past its limits, and misfires follow. Do not regap used iridium or platinum plugs. The fine center electrode can fracture. If the gap has drifted, replace the plug. Blow loose debris out of plug wells with compressed air before removing anything. This prevents particles from falling into the combustion chamber. When installing new plugs, start them by hand to avoid cross-threading, then torque to the manufacturer's dry thread specification. If you apply anti-seize, reduce your torque value by 15 to 20% because anti-seize changes the torque to tension relationship. Dielectric grease goes on the inside of the coil boot only. It is an insulator. Do not put it on the metallic contacts or the plug threads. A bad coil just causes a misfire. Number 8 on the list can actually kill you, and I am not being dramatic about that. An exhaust leak in the wrong location allows carbon monoxide into the passenger cabin. Carbon monoxide is odorless, colorless, and accumulates to dangerous concentrations without warning. This is especially dangerous in cold weather with windows closed. An exhaust leak is not a cosmetic annoyance. It is a potential emergency. Beyond the safety issue, an exhaust leak upstream of the catalytic converter introduces false air into the exhaust stream near your oxygen sensors. The sensors report a lean condition. The ECU adds fuel to compensate for a problem that does not exist inside the combustion chamber, and fuel economy drops as the engine chases ghost data. For temporary repair, use exhaust repair tape, header wrap, or high-temperature repair compounds. Surface preparation is everything. High-temperature sealant handles pinholes. Exhaust bandage kits handle larger gaps. For flange leaks, replace the gasket and inspect the flange surfaces for warping. Ask anyone who has been through this cycle. Budget for a proper welded repair. That weld will outlast 3 rounds of temporary patches. The next fix costs $3 from the grocery store baking aisle and outperforms a $50 name brand coolant flush. Trick 7. Cooling system failure rarely announces itself dramatically. The heater stops blowing as hot as it used to. The temperature gauge creeps higher than normal on long drives. The coolant looks rust-colored through the reservoir. By the time you see that rust color, acidic degraded coolant has already been attacking aluminum components from the inside for months. Heater cores, radiator tubes, water pump impellers, thermostat housings. Citric acid from the grocery store. 1 to 2 tablespoons dissolved in distilled water creates a mild acid flush that removes light scale from the cooling passages. Run the engine at operating temperature for 15 to 20 minutes with the heater on full blast. Then drain completely and refill with fresh coolant at the correct mixture ratio. On trucks with sluggish heater output, the $50 commercial flush product showed minimal improvement. 2 cycles of citric acid and distilled water restored full heat output. $3 versus $50. The grocery store won. If your vehicle has bleed screws on the thermostat housing or upper radiator hose, use them. Air pockets trapped in the system cause hot spots and erratic temperature readings. Always match the manufacturer coolant specification. Mixing incompatible formulations creates its own set of problems. From there to a trick that is entirely about discipline. Because losing patience for 1 second turns a $5 job into a $300 nightmare. Number 6 is about penetrating oil, and the lesson is not about which brand to buy, it is about time. I have seen it happen more times than I can count. One impatient pull on a frozen bleeder screw snaps it clean off. A $5 brake bleed becomes a $300 caliper replacement. A regular Tuesday at any garage that does northern cars. The technique is multiple applications spaced over time. Spray, wait, spray again, wait longer. Let the oil wick into the threads through capillary action. Severely corroded fasteners sometimes need overnight soak time. Patience is not a suggestion here. It is the entire strategy. I know that sounds dramatic. It is not. Heat cycling works alongside penetrant. Apply heat to the surrounding casting with a propane torch. Metal expands, the gap between the bolt and casting opens, and the corrosion bond breaks. Let it cool, apply more penetrant, then use slow, steady pressure with a long-handled breaker bar. Impact wrenches deliver shock loads that snap corroded fasteners. A breaker bar gives you feedback through your hands about when a fastener is about to release versus when it is about to break. For snapped bolts, use bolt extractors. Chase damaged threads with taps and dies. Trick 5 starts with the sound that makes everyone in the parking lot look at you, that high-pitched squeal from under the hood, usually at cold startup or when you turn the wheel. Most people either ignore it or reach for belt dressing. Belt dressing quiets the noise for about a week, and then the belt is worse than before. The serpentine belt drives the alternator, the power steering pump, the water pump, the air conditioning compressor, and the tensioner and idler pulleys. When it squeals, the belt is intermittently gripping and slipping on a pulley surface. Belt glazing, cracking, fluid contamination, a worn tensioner, pulley misalignment, or a failing accessory bearing. You might think a new belt fixes the squeal. It almost never does. People waste money replacing the belt without checking any of those other components. The new belt squeals again within a week because the root cause was never touched. The bar soap trick circulates constantly in forums. Rub a dry bar of soap on the ribbed side of the running belt, and it often quiets immediately. The residue washes away or attracts dirt that accelerates wear. Soap does not restore tension, fix misalignment, or replace worn bearings. The test that actually solves the problem costs nothing. Spray a small amount of water onto the running belt. If the noise goes away or diminishes, the belt is slipping against the pulley, meaning worn belt, low tension, or contaminated pulley surfaces. If the squeal continues despite the water, you are looking at a bearing or alignment issue, not the belt itself. Remove the belt and briefly run the engine. If the noise disappears, the problem is within the belt-driven accessory group. If it persists, the noise is coming from somewhere else entirely. Spin each pulley by hand and feel for roughness. Use a mechanic's stethoscope to isolate bearing noise to a specific component. Cold startup squeal that fades as the engine warms often points to a glazed belt. Squeal under load or during steering points to the power steering pump. Constant squeal at all temperatures usually means a bad tensioner or failing bearing. Replace worn belts, faulty tensioners, and any accessory with failing bearings. Now, if this video is delivering value and you want YouTube to show it to other drivers who need it, hit the like button right now. Because number 4 on this list is the one that divides mechanics into two camps, and using the wrong product in the wrong situation causes real engine damage. Number 4. 3 products that people constantly treat as interchangeable. Each one does a fundamentally different job, and applying them out of sequence costs more than doing nothing. Start with PEA-based fuel system cleaners. Polyethyramine. Products like Chevron Techron and Redline SI1. Pour it in the fuel tank and drive normally. The chemistry targets deposits that foul injectors and ports. Lowest risk, most routine first step. If fuel trims are drifting lean or throttle response has become sluggish, try a tank of PEA cleaner before escalating to anything more aggressive. Validate with fuel trim numbers on your scan tool, not with how the car feels. Seafoam shines as an upper intake and throttle body cleaning tool. Warm the engine, remove the intake ducting to expose the throttle body, and spray seafoam while the engine idles at roughly 2,000 revolutions per minute. The vapor gets drawn past the throttle plate into the intake manifold. After the treatment, let the engine hot soak briefly, then drive to burn off loosened residues. And this is the moment everyone on YouTube loves. The exhaust billows dramatic white smoke during the burn-off phase. It looks like the engine is on fire, every single time. Understand this. That smoke is visually satisfying, and it is not proof the treatment worked. Only normalized fuel trims or restored compression numbers constitute genuine evidence. Smoke is theater. Data is proof. Berryman B12 Chem Tool is the aggressive option, used for heavy varnish removal, piston soaking, and deep fuel system cleaning. The piston soak introduces a conservative amount of B12 through the spark plug holes, and allows a dwell period where the solvent softens deposits on the pistons and rings. If solvent enters the crankcase, you must do an immediate oil and filter change, no exceptions. The dissolved contaminants will destroy bearings if left circulating. Shield rubber and painted surfaces. Work away from open flames. The piston soak is a last resort for engines showing compression loss or stuck rings. For direct injection, engines with hardened carbon on intake valves, chemical cleaners often fall short entirely because fuel no longer washes over those valves. Walnut shell blasting is the professional method for removing those deposits without damaging valve surfaces. Trick 3 is the sensor that controls every fueling decision the ECU makes, and cleaning it costs $8 instead of the $200 to $400 replacement quote you get at the dealership. If the information going into the engine computer is wrong, every decision coming out is wrong. The mass airflow sensor measures incoming air mass, so the ECU can calculate exactly how much fuel to inject. When contamination coats the sensing element, that accuracy degrades. The symptoms hit everywhere at once: stumbling idle, stalling, hesitation, decreased power. Fuel trim codes like P0171. Clean the MAF when diagnostic data points to it, not as a routine item every oil change. Use a purpose-made MAF cleaner spray. These formulations evaporate without leaving residue. High-concentration isopropyl alcohol at 90% or greater works as an alternative. Remove the sensor from the housing, spray in short bursts from a moderate distance, and never touch the sensing element. Let it air dry completely before reinstalling. The throttle body is closely related, but presents a different risk. Carbon deposits build up around the butterfly edge and bore, interfering with throttle plate movement. Modern throttle bodies often have protective surface coatings. This one catches even experienced mechanics. Certain carburetor cleaners strip these coatings completely. Once gone, friction increases, the throttle plate starts sticking, and idle gets worse than before the cleaning started. Spray throttle body cleaner onto a lint-free rag or soft nylon brush, not directly onto the bore. Wipe deposits, focusing on the seat line and edges. After cleaning, perform a throttle or idle relearn procedure. The carbon the ECU had learned to compensate for is now gone, but the learned parameters are not. Skip the relearn, and the idle will feel wrong. For Honda Civic owners, this step is especially important. Warm the engine to operating temperature, switch off all accessory loads, and let it idle for a stable period so the ECU can recalibrate. Now the list gets personal. I genuinely consider number 2 the most common and most expensive misdiagnosis in automotive repair, and the actual fix costs less than a cup of coffee. A car starts showing mysterious symptoms: dim headlights, a charging warning on the dash, slow cranking in cold weather, intermittent no-start conditions, flickering dash lights. The owner takes it to a shop. The shop recommends a new alternator. $350 later, the car goes home, and within 2 weeks, every symptom returns. Then comes the battery. Another $160, still not fixed. The actual problem the entire time was a corroded bolt on the engine block. A $2 fix, 15 minutes, $510 in parts that were never broken, $2 for the bolt that was. Electrical gremlins on modern cars trace back to corroded ground connections more often than any other single cause. When a ground corrodes, resistance builds at that point. And resistance does strange things across the entire electrical system. Dim lights, slow cranking, charging warnings, parasitic drain, random codes, module communication errors. Every one of these can and does trace back to a corroded ground. That misdirection is what makes shops profitable. Remove the ground connection. Clean the contact surfaces on the wire terminal and the mounting point with a wire brush or sandpaper until you see bright bare metal. Reinstall and torque correctly. Apply dielectric grease to the outside of the assembled connection to seal it against moisture. Do not clean one ground when a problem appears. Sweep every ground on the vehicle in a single afternoon. Battery terminals, engine to chassis ground strap, body grounds, transmission ground, every accessible point. One afternoon eliminates an entire category of future problems. For battery terminals, disconnect the negative first, then the positive. Neutralize white or green corrosion with a paste of baking soda and water. Scrub the posts and the inside of the clamps with a battery terminal brush until you see bright metal. Reinstall positive first, then negative. Torque properly. Verify your work with a multimeter set to DC voltage. Measure voltage drop across each ground connection under load. A clean connection reads very close to 0 volts. Anything above 100 millivolts means that connection has resistance and needs more cleaning. A healthy battery at rest reads 12.6 volts. Under cranking load, it should stay above 10.5. With the engine running, the charging system should produce between 13.8 and 14.4 volts. Trick number 1 is the most powerful tool on this entire list because every other trick connects back to it. Measure first. That starts and ends with your scan tool. Not used as a code reader, not as a check engine light eraser, used as a live diagnostic window into what the engine is actually doing. The metric that ties almost every trick in this list together is fuel trims. The engine computer constantly adjusts the air-fuel mixture based on feedback from the oxygen sensors. Short-term fuel trim is the immediate real-time adjustment. Long-term fuel trim is the learned correction that builds over time. 0% means the ECU is delivering exactly the fuel its base programming calculated. Positive numbers mean it is adding fuel because the mixture is lean. Negative means it is pulling fuel because the mixture is rich. A healthy engine lives between -5 and +5%. Anything outside that range is the ECU telling you something is wrong. Long-term fuel trim at +10% or higher means the engine is lean. A vacuum leak from trick 10, a dirty MAF from trick 3, a failing PCV valve from trick 10. One number tells you exactly which section of this list to address first. Negative trims mean the engine is running rich. A leaking injector, a stuck open purge valve, or a coolant temperature sensor telling the ECU the engine is cold when it is warm. Your upstream oxygen sensor should fluctuate rapidly between lean and rich as the ECU hunts for the ideal mixture. If it is stuck at either extreme, the sensor may be failing, or the engine condition is so far out of range that the ECU cannot compensate. The downstream sensor should hold a relatively steady voltage when the catalytic converter is working properly. If it mirrors the rapid fluctuation of the upstream sensor, converter efficiency is degraded. A real situation. A car has a rough idle and a P0171 code. Pull up the scan data. Long-term fuel trims at +12%, short-term trims jumping. The engine is genuinely lean, not throwing a phantom code. Check for vacuum leaks using the spray technique from trick 10. Clean the MAF using trick 3. Check the PCV valve with the shake test from trick 10. Each fix moves the fuel trims closer to zero. When they land back in the normal range, the rough idle is gone, and the code does not return, because the actual problem was fixed, not just cleared. Most people erase the code and hope it stays away. That is not diagnosing. That is gambling. The scan tool is what makes the difference between guessing and knowing. Start with whichever trick matches your symptoms right now. Rough idle, start with the PCV shake test. Electrical gremlins, start with the ground sweep. Belt squeal, use the water spray test. Everything connects back to the same principle this video opened with. Measure first, always. Drop a comment with which trick you are checking this week. And if someone you know is about to spend $300 at a shop on a problem that might be a $4 fix, share this with them. One more thing before you go. There is one part that causes more misfires than anything else covered in this video. It fails completely silently. No warning light for weeks, sometimes months. 99% of drivers find out about it only after the damage is already done. I covered exactly what it is, how to test it in under 2 minutes, and why most mechanics never catch it early in the video on screen right now. If you have ever had a misfire, or if you want to make sure you never do, that is the one to watch next.